Tonight's notes is lesson 8 and 9 combined from the modules from Engage New York. It's in your textbook also, other examples in chapter 5, section 3 and 4. So you can find this in your green textbook, section 5, chapter 5, sections 3 and 4. Some points to remember. We're going to represent proportional relationships now with equations. Well, we've seen proportional relationships in a table, finding a constant, and in a graph, looking for, is it a straight line and does it go through the origin? We're going to take those things that we know and apply it to equations. Some points to remember. Proportional relationships have a constant ratio. It's called the unit rate. The unit rate can also be called the constant of proportionality. In lesson 2.7, we now gave it a letter. It's called K, that constant that we've been finding when we do y over x. So how would we use what we know about the constant of proportionality? Y over x gives us the constant, the unit rate, to write an equation. Here's an equation. Y over x equals K. That is an equation. We took our y values in our tables, divided by our x. Did it always come out to be a constant? Yes, then it's a proportional relationship. You can see that I drew the triangle over here. Please draw it on your paper. Because yes, y does equal k times x. Or y over x, there's the division line, equals k. You heard me say y does equal the constant times x. We did that when we were building tables. We would take our constant, $15 every lawn, multiply it by the number of lawns. So if Timmy mowed 2 lawns, 2 times 15, we would get $30. We would get the y value for that table. We would take a constant times the x value of the table to get the y value. So that's 2 forms of the 3 forms that this triangle gives us. There's one other variable we could solve for. We could figure out, okay, what's x? Cover up that x. X is equal to y divided by k. So the third form of this equation, our x values, to get them, if we didn't know them, we could take our y values and divide them by the constant of proportionality called k. That constant rate that we were finding, or that constant ratio that we were finding. So example 1 here. So turn your page to example 1. Do we have enough gas to make it to the gas station? Your mother has accelerated onto the interstate, like going on the thruway, 90. It's called an interstate. Beginning a long road trip, and you notice that the low fuel light is on, indicating that there's half of a gallon left in the gas tank. That is not very much gas. The nearest gas station is 26 miles away. So the next rest stop on the thruway or the next exit on the thruway is 26 miles away where there's a gas station. Your mother keeps a log where she records the mileage and the number of gas gallons purchased each time she fills up the tank. So this is her log, what they're calling the log. She keeps a little book with a chart in it. If I put 8 gallons of gas in the car, I go 224 miles. If I put 10 gallons of gas in the car, she went 280 miles. If she put 4 gallons of gas in the car, she would go 112 miles. Use the information in the table below to determine whether you will make it to the gas station before the gas runs out. Remember, we only have half of a gallon left. I kept that on here. And the gas station is 26 miles away. So we have to know something about our gallons and our miles, which is what's in our log or in our chart. You know that if you determine the amount of gas that our car consumes in a particular number of miles, called miles per gallon, then you can determine whether or not you're going to make it to the next gas station. Find the constant of proportionality. Well, miles that you drive depends on how much gas you have. The y variable is also called the dependent variable. We're going to learn that this lesson. The x variable, the gallons of gas, that goes on the x, that's called the independent. What you put on the x-axis of a graph, that's called the independent variable. So the miles change, variable, and the gallons change in this chart, variable. So miles depend on how much gas is in your car. So they are the dependent variable. That's how I figure it out. Miles depends on gas. So find the constant of proportionality. Well, we know to do that, you have to do y over x to equal that, k. They want you to find k. Find k and explain what it represents in this situation. It could have said in this context, meaning in this little story about mom and the gas in the car, in the situation. So y divided by x, got to do it every time. When I've gone 224 miles, or mom went 224 miles, she had 8 gallons of gas. So 224 divided by 8, oh, that's 28 miles per gallon. That's the rate, the constant of proportionality. Is it the same when she drove 280 miles? She had 10 gallons of gas. Well, yes. Fast way of doing that, take away the zeros. You're dividing by 10 when you do that. That's equal to 28 miles per this 1 gallon down here, per gallon. 112 miles on 4 gallons of gas. Dividing that, you do get the same mileage, 28 miles per gallon. Describe or explain what it means in the context. Mom gets 28 miles per gallon. And yes, I could use that well-known abbreviation right there for that answer. Sabling my question. Sentence answer box label. Write an equation. Write an equation that will relate the miles driven M to the number of gallons of gas G. Miles per gallon. Oh, you know what? When I did, I could make a triangle out of this. My miles divided by my gallons, gave me my constant. So my constant, 28 miles per gallon times how many gallons I have, will give me my miles. That's what it's asking. Tell me what M is. So M is equal to M equals K times G. My constant times my G. Or you could think of it as Y. This is the Y variable, the miles, equals the constant that we figured out times the X, the gallons. Y equals KX. You'll hear me say that over and over again. In this context, Y is M for miles, G is, X is the G, we're going to use G is for X, the gallons. So we're changing the Y equals KX to M equals KG, replacing the Y and the X with the true situation, miles and gallons. So that's the equation, we did that. Letter C, knowing that there is a half of a gallon left when the light comes on, will she make it to the nearest gas station? So a half a gallon. I know she can go 28 miles with 1 gallon. She needs 1 gallon to get there. Okay, well, she's only got half of a gallon. So she's not going to get 28 miles. And how far does she have to go? The nearest gas station, I circled it up above, was 26 miles away. Well, 1 gallon, half of it is a half a gallon, so half of 28 would be, nope, she's not going to make it. You're only going to go 14 miles. So, no, will she make it? No, Mom will not make it to the next gas station. So she's going to have to call AAA or something. Mom will not make it to the gas station. She's going to run out. She only has 14 miles left. She's going to run out. Should have got gas before she got on the thruway, or knew that the gas station was closer. Part D, using the equation found in Part B, okay, my equation was miles is equal to the constant times the gallons. Determine how far your mother can travel on 18 gallons. Okay, AAA must have came, filled up her tank, gave her 18 gallons of gas. Now they're on the throughway again. How far can she go on 18 gallons of gas? Solve the problem in two ways. Okay, I'm going to solve for miles first. How far can your mother travel on 18 gallons of gas? Well, if I take my constant of 28 miles per gallon times my now 18 gallons in the tank, 28 times 18, I'm going to get 504 miles. That's one way, using the equation in part B. Okay, now I'm going to change the equation around a little bit. And I'm going to say, okay, well, if I take my miles, if I go back to my little triangle up here, if I take my miles and divide it by my gallons, it's got to equal that constant. So if I take miles, y divided by x equals k, right? M is now my y, miles, x is the g, gallons. So if I take my miles and divide it by my gallons, I should get 28. How many miles? I don't know. How many gallons? 18. What's the k? Well, I know that. It's 28. This is a division equation. How do you solve it? You multiply. So multiply each side of the equation by 18. Cross cancel your numerator and your denominator there, and you get miles equals 28 times 18, 504 miles. So I did it two ways, just like it asked. Part E, using the equation found in Part B, determine how many gallons of gas would be needed to travel 750 miles. 750 miles, okay, so 750 miles. I'm going to use this equation, miles equals kg that I have there from Part B. How many miles can I go? My constant is 28 miles per gallon. How many gallons do I need? Well, my miles is 750. How many gallons do I need? I don't know. It's G. So 28 times what number equals 750? This is a multiply equation. So to solve a multiply equation, you divide on both sides. Show that cancel step. 750 divided by 28 comes out to be 26 and 8/10 gallons, or G for gallons. And I'm not going to sable this one for now because I just want to save some time. So, but I will write the label on it correctly. So 26 and 8/10 gallons of gas is needed to travel 750 miles. That's a long trip. Example 2. Andrea is a street artist in New Orleans. She draws a caricature, cartoon-like portraits of tourists. People have their portrait drawn, those caricatures, and then come back later to pick it up from her. The graph below shows the relationship between these two quantities, these two variables. The portraits, number of portraits, notice that's on the y-axis, and they're calling it n now. See the n here? Number of portraits, n, and the amount of time, time in hours, that's on the x-axis, and they're calling it capital T, needed to draw the portraits. Write several ordered pairs. Okay, ordered pairs. X comes first, order counts, Y comes second. From the graph, and explain what each ordered coordinate pair or ordered pair, oh, they changed the word here, coordinate pair, which means ordered pair, means in the context of the graph. So using the story or the variables of the graph. So I'm going to look for points that are exactly where two lines meet, like this point here, 2, 3. So that's an ordered pair, easy to read. So what does the point 2, 3 mean? It means in 2 hours, 2 comes first, in 2 hours, Andrea draws 3 portraits, or 3 caricatures, or 3 pictures, but I'll say portraits because it's easier to spell than caricatures. So in 2 hours, go over 2, she draws 3 portraits, right? Another nice easy point to read is in 4 hours. And I'm not going to write all this out, but you're going to listen to me say this. In 4 hours, Andrea draws 6 portraits, right? In 6 hours, Andrea draws 9 portraits. So that's the ordered pair 6, 9. I said it, I didn't write it all out. Part B, determine the constant of proportionality and explain what it means in this situation. Well, the constant of proportionality is y over x equals the constant of proportionality, okay? So the y, now I've got to do it in the opposite of ordered pairs and put the y on the top, the number of portraits. Determine the constant of proportionality. Well, I could take these 3 points and figure it out. 3 over 2, 3 divided by 2, oh, that's 1.5. 6, the y over the x over 4, so now I'm going the opposite, 6 over 4, y over x equals the k, I get 1.5. And 9 over 6, that equals 1.5. Another way I could do it even faster than doing those 3 points is come right here to the x-axis. When it's 1 hour, where does it hit the graph? Right there at 1.5. The point when y is 1.5, my x is 1 hour. That's my 1.5 portraits that she paints. Portraits that she paints per 1.5 portraits per hour. Remember, constant of proportionality. It means unit rate. How much for 1? The x being the 1. The bottom number, the x. The x being the 1. Oh, x equaling 1, x equaling 1. So go to your graph. Let me erase some of this because it's getting messy. Go to your graph. Find x equals 1 and see where it hits the real graph, the blue line here, 1.5. And yes, without doing a couple of these, 3 over 2, 6 over 4, and 9 over 6, did I know that this was exactly 1.5? No. But it did help me. I could have just used one of these points, like 9y over 6x equals 1.5. Then I would go right to that. If it's not an easy to read point, which that one is not, sometimes at 1 it crosses exactly at 5, like today's quiz, that Jane can paint 5 clay figurines in 1 hour. So in 1 hour, Andrea can paint 1.5 portraits, caricatures. So C says, write an equation that would relate the number of portraits. Remember, they called number of portraits N. Number of portraits. The number of portraits she makes is 1.5 is the constant times the time, 1 hour. Remember, this is y equals k times x. That's the equation relating the number of portraits, which they called N, equals the constant, which we found, which was 1.5, times the capital T, the time. I could have said y equals 1.5x, but I wanted to put it in the relationship of what variables they used, the T and the N. This is perfectly okay. Could I have said y over x equals the constant 1.5? Yes. Or putting it with this letters, could I have said N, number of portraits, the y variable, divided by x, the time, equals 1.5? Yes. There's lots of ways I could have answered this question. There's 4 of them. So, the next question, last one, Al's produce stand. Al's produce stand sells 7 ears of corn for $1.50. 7 ears of corn cost $1.50. We've got money here. Money always goes on the top, so I know this is y. And this must be x. Barbara's produce stand sells 13 ears of corn for $2.75. Write 2 equations, one for each of the produce stand, that models the relationship between the number of ears of corn sold and the cost. Then use each equation to help complete the tables below. Okay, so I guess I got to answer these questions first. Which makes more sense to use as the unit rate? Ears of corn per dollar. So how many ears can you get for $1? Or dollars per corn of ear of corn. Whoops, I said that backwards. Dollars per ear of corn. Well, you can only buy one ear of, you can't buy part of an ear of corn, can you? No. So this makes sense. Per one ear. Plus, I know money always comes first. So money's good. That makes sense. Dollars per ear of corn makes sense. Why? Because you can purchase whole ears of corn. This is where the 1 needs to be. We're trying to figure out what's the better unit rate. Which one's the Y and which one's the X. You can purchase whole or ears of corn by ones, right? You buy 1 ear of corn or 2 ears of corn or 3. You don't buy 4 1/4 ears of corn. You can purchase whole, meaning 1, ears of corn. And money goes on the top. We know that. Based on the previous question, which would be the independent variable? The independent variable is always the X. That's the ears of corn. I can control how many ears I'm buying. Usually the independent variable is the thing you can control. Do I want 1 ear of corn, 2 ears of corn, 3 ears of corn, 7 ears of corn? No, I'm going to buy a dozen today. So I can control that. So the ears of corn is the X, or the independent variable. Independent. Ears of corn is the independent variable. That's what I can control. Which would be the dependent variable? That would be the cost, because the cost depends on how many ears you buy. If you buy 1, it's $1.50 at Al's. If you buy 10, it would be $11.50. Cost depends on the number of ears of corn. So money is the dependent variable. It's the Y. Money is on the top, Y is on the top, Y over X equals K. So the dependent variable, that's the Y-axis. The independent variable, that's the X-axis. Lots of times you can control the X-axis, but not always. Cost depends on the number of ears of corn. So cost depends on the number of ears of corn, so it's the dependent variable. D, determine the unit rate or constant of proportionality for Al's stand. Well, they told us that for 7 ears of corn, it's $1.50. So what's $1.50 divided by 7? That will give me what 1 ear of corn is. And when you divide that, I got to get the constant. What is it? It's decimal point 2.14585.7, and it keeps going. So since it's a 4 here, we don't have money in the thousands. We have money in the hundredths. So I'm going to erase that 4 and say, oh, Al's stand is 21 cents for each ear of corn. So I know that answer. Determine the unit rate for Al. So my Y divided by my X was my $1.50 divided by 7, which gave me the 21 cents. Determine the unit rate or constant of proportionality, the K, Y over X equals K. So I've got to do the same thing now for Barbara's stand. And at Barbara's stand, it was $2.85 for 13 ears of corn. $2.85 divided by 13, you get decimal point 2189, and yes, it's a number greater than 5 here. So we're gonna round up to 22 cents per every ear of corn. That's what it means. 21 cents per ear of corn at Al's. 22 cents per ear of corn at Barbara's. How do you write an equation for a proportional relationship? Well, you write y equals k times x. That's what you write. That's the general formula every time. Write the equation for Ales. Well, we found Ales K. His cost is equal to 21 cents times his ears of corn. Y equals 21 cents times X. What is Barbara's? Y equals 22 cents per ear of corn times the corn. So her cost is 22 cents times the ear of corn. So now we got to fill in the table. So every time I'm multiplying here by 21 cents. So 21 cents gives me $2.94. Multiplying 21 by 21 cents, I get $4.41. Uh-oh, this time they gave me y and I got to figure out x. X, remember, we figured this out, that x is equal to the k divided by y. Well, I know what the k is. The k is 21 cents. If I take the 21 cents and I divide it by the $50, wow, we're buying lots of ears of corn. Yes, it's 238 ears of corn. Must be having a big festival or something, and we're going to sell ears of corn. And with Barbara, hers was 22 cents every time. So times 22 cents, I would get $3.08 times 22 cents, 21 times 22 cents would give me $4.62. And remember, x is the k divided by that 50, same process. Her k now is the 22 cents. Sorry, I'm writing over this. Divided by 50, you can only get 227 ears of corn at Barbara's stand. If you use E, now they want me to use E, ears of corn, E, and C for cost, okay, so cost was the Y, and E is the ears of corn. What is it for ales? Okay, Y is now called C for cost, and X is called E for ears. Well, I'm just replacing those general letters, Y and X. I'm going to use the context, or the ones in this situation. Barbara, its cost is equal to 22 cents times the ear of corn for Barbara. Cost is 21 cents times the ear of corn for Ale. And that's what we're going to be working on in class, equations.